In this video, we'll be discussing objective 1 from H.C. Verma for X-rays. Let's start with the first question. X-rays beam can be deflected by electric field or magnetic field or by both or by none of them. So as an X-ray beam is nothing but a collection of photons of very high frequency and energy, we can say that it will neither be reflected by electric field and magnetic field because it don't have any charges. It is just made up of photons. Okay. The next question, consider a photon of continuous X-rays coming from a Coolidge tube. Its energy comes from. As we know that the continuous part of the spectrum is comes from the loss of kinetic energy of an striking electron when it strikes the metal surface. Or we can say in this, out of these four options, the first one is the best suitable one, the kinetic energy of the striking electron, and the remainings are wrong. The next question is the energy of a photon of characteristic X-rays from a Coolidge tube. Again, the characteristic part of the spectrums comes from the transition. Okay, transition of the target metal, an atomic transition which takes place in the target metal. So by these characteristic part of the X-ray spectrum, we can also specify that which element is being used as the target metal. Okay. The next question, if the potential difference applied to the tube is doubled and the separation between the filament and the target is also doubled, the cutoff wavelength. As we know that cutoff wavelength is simply dependent on the accelerating voltage. By this expression, lambda is equal to hc by ev accelerating. V naught is doubled, so lambda will simply become half. It is not dependent on any other factor like distance or anything else. So by doubling the accelerating voltage, we'll have half of lambda min. Okay, so option C will be correct. In the next question, if the current in the circuit for heating the filament is increased, again the cutoff wavelength, as I already told that cutoff wavelength is dependent only on the accelerating voltage and no other factor like distance or this current in the heating filament. Current in the heating filament basically controls the number of the number of thermoelectrons which are ejected from the metal plate and which uh, controls the intensity of X-rays but not the cutoff wavelength. Okay, so we can say by changing the filament current, the cutoff voltage will remain same. In the next question, Mosley's law for characteristic X-rays is given by this, and we have to find whether A or B, which they are dependent on material, whether A is dependent or B is not. And out of these factors, we can say A depends on the transition or the states in which transition is taking place from n equal to 1 to 2 or from 3 to 1. So A depends on those factors, not on the material. Again, the B is called the screening factor. It depends again on the number of shells an electron is jumping to get back to its original shell. So again, it is independent of the atomic number. Okay, so both A and B are independent of the atomic number or material. Then the next question, frequency of K alpha of different materials are measured. Which of the following graph may represent the relation between frequency and the atomic number? As the graph, the relation is already given, but in this we have to find frequency. It is root of frequency. So squaring the curve, we get frequency is nothing but z minus b whole square into this, and it's a parabolic function on which frequency will be represented on y-axis and z will be on x-axis. So it will be parabola like the given x graph. Hence the correct graph is D. In the next part, there is a X-ray beam which is coming from X-ray tube. Okay, so in that beam or in that experiment, we can say we have all the possible wavelengths which are greater than a minimum wavelength. Okay, and we don't get any wavelength which is less than lambda min, of which expression I already gave you, that lambda is equal to uh, hc by ev naught. So we get all the possible all the wavelengths which are greater than that. So obviously we'll get visible light, uv rays, infrared, radio in this experiment. From the graph also we can say that there's no wavelength which is less than this lambda min, but all the possible wavelengths which are greater than this are available. Okay, and next question, one of the following wavelength is absent and the rest are present in X-ray coming from a Coolidge tube. Which one can be the absent wavelength? As we know, minimum wavelengths, or out of a given value, minimum wavelength can be the only wavelength which is absent. So if we get 50 picometer, we are bound to give bound to got this 75 and 100 picometer. But if we get 25, then again 50, 75 and 100 will also be found. So the only wavelength which is absent is 25 picometer. In the next question, we have to find the relation between intensity and wavelength out of the following graphs. These are the graphs, and we have to comment on which the potential difference is more or on which z is more. As we can see that the minimum wavelength for the bold graph is a, so the is smaller, so we can say va is greater than vb. Okay, as wavelength is inversely proportional to k alpha for graph, bold graph, lambda for bold graph is larger, so obviously for this transition will be smaller, so za will be smaller than zb. We can look at the diagram. We can see in the graph that sorry, in the graph, not in the equation, that frequency is proportional to z minus b whole square and frequency is inversely proportional to wavelength. So if wavelength is more, as in bold graph wavelength was more for first k alpha transition, so wavelength is more, so z has to be less, so za is smaller in comparison to zb. Okay, and we can look at the next question now. 50% of X-ray coming from a Coolidge tube is able to pass through a 0.1 mm thick aluminum foil. If the potential difference between the target and filament is increased, what fraction will be able to pass through the same foil? As by increasing the potential difference, uh, the X-ray photons will have more energy. So they will have more energy, they will be able to penetrate up to a larger thickness. So more than 50% will be able to cross this 0.1 mm, because 50% were already crossing that 0.1 mm thick aluminum sheet. In the next question, if we want to if we want only 50% of photons still crosses, then it's quite obvious that we have to increase the thickness of the aluminum foil so that only 50% are allowed to pass, so the thickness of the new aluminum foil will be greater than the original, which is 0.1 mm. So new aluminum coil should have a thickness greater than 0.1. Option B in this and option B in that. In the next question, if that X-ray from a Coolidge tube is incident on a thin aluminum foil, the intensity of X-ray transmitted by the foil is I naught. The heating current is increased. Again, by increasing the heating current, we are increasing the intensity. and the intensity of X-ray transmitted by the foil will also increase, because it will be just a certain percentage that will be absorbed or stopped by the foil. So if the value increases, then its percentage will also increase. Okay, so the intensity of X-rays transmitted through the foil will be greater than I naught. In the last part, there is a visible light passing through a circular cone hole from a diffraction disk of radius this on the screen. If X-rays pass through the same setup, the radius of the diffraction disk will be, okay, as the visible light is making a disk of 0.1 mm radius, the X-rays will be able to form a disk which is less than this radius, because uh, lesser the wavelength and smaller will be the effect of diffraction. Okay, so we can see diagram that these wavelengths, these are the visible light wavelengths, they are diffracted more, so they will form a larger disk, and X-rays will be diffracted by a very small angle. Okay, so its aperture will be small, so radius should be smaller than 0.1 mm. Okay, thank you. The answer is D, and 12 is also D, and in 13 is also D, because I've explained it already that by increasing the potential difference, energy will increase, so more number of more than 50% will cross, and to allow only 50%, the thickness has to be increased, and the intensity that will transfer through the coil or through the foil will also be greater than the initial intensity. And this question number 14, the answer is B.